Well, probability, something everyone's interested in. How likely are things to happen? So we've got some questions here, and in the usual way of GCSE exams, they've taken a fascinating subject and squeezed all the interesting stuff out of it. On the probability scale below, mark with a cross the probability that it will snow in London in June. So what they're just testing to see here is, do you know what the numbers mean? London in June is going to be pretty warm, hopefully, unless global warming freezes it. So it's pretty unlikely it'll snow. I wouldn't say it's impossible, it's just very unlikely. So remember, 0 is impossible, as in really impossible, and 1 is certain. And you can't have anything higher than that because certain means certain, and impossible means it can't happen. So snowing in London in June, pretty unlikely. On the probability scale below, mark with a cross the probability it will rain in Manchester next year. Okay, well, I'll be honest with you, I have not been to Manchester, but I'm pretty certain it's pretty likely to rain. I'm not sure I'd go as far as to say it's certain, but it's as close to certain as makes no difference. What is the probability that you'll get a head when you flip a fair coin? Well, it's a half, or 0.5, or 50%. But if you really don't want any marks, if you really don't want to score anything, then it's not 1 to 2. That means something different. 1 to 2 means, well, it means you've got 3 things, so it's out of 3. So definitely not that. That would lose you marks. It's any of those. Anthony spins a fair 5-sided spinner. He then throws a fair coin. List all the possible outcomes he could get. The first one has been done for you. So here's our clue: 1 and a head. So let's carry on. He could get 1 and a tail. This is a system. I know now that's all the 1s done. Now I'm going to do the 2s. It could be 2 and a head, or it could be 2 and a tail. And again, I'm using a system here, and the system is I'm just copying what's happened here. So it went head then tail, so I did head then tail. Let's keep going. It could be 3 head, or 3 tail, or 4 head, or 4 tail. Finally, 5 head, or 5 tail. And there we go. And because I use a system, I know I've got them all. Anthony spins a spinner once and throws the coin once. So spinner gets spun once, throws the coin once. Work out the probability he will get 1 and a head. And that's really simple because we've just worked out all the possibilities, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the possibilities. So our probability is out of 10, and only one of them has got a 1 and a head in it. So it's 1 out of 10, and I'd write it as 1/10. You could write it as 10% if you'd like, or you could write 0.1 because that's a 10th, but not, see if you can guess what I'm about to write, not this. That would be evil and wrong. You wouldn't get any marks. Right, question 3. This spinner is used at a fairground. What a fun fairground that must be. When the spinner lands on a W, the customer wins a prize. Great. Okay, so you can just see just how unfair it is there, because there's only 3 W's. The fairground owner expects 1,000 customers to have a go. Estimate the number of prizes the owner should buy. Now, this is your sort of worst nightmare sort of question, because it's not really telling you what to do very clearly, but it's clearly a probability question. It's got a spinner in it. So the probability of winning is, right, there's 3, and it's out of 1, 2, 3, 4, 5, 6, 7, 8. So it's 3 out of 8. So 3/8 of the time you're likely to win. So How did I know to do this? Well, this is the difficult thing with these questions. There isn't a simple answer. I looked at that, it's got a spinner in it, and I thought that's a probability question, so I thought I'd work out the probability. Now, I've got the probability. I can see that 3/8 of the time I'd expect somebody to win. So if 1,000 people have a go, then 3/8 of them should win, shouldn't they? So 3/8 of 1,000. And I know that 1/8 of 1,000, so I do 1,000 divided by 8, and that gives me 125. I'll talk about how I know that in a minute, because this is a very common non-calculator sort of question. But I want 3/8, so this is 1/8, so 125 times 3, which is 375, that's 3/8. So 3/8 of 1,000 is 375, and you can see it's just less than half. Half would be 4/8, and half of this would be 500, so it seems reasonable. So estimate the number of prizes the owner should buy. The owner should buy around 375 prizes, because the probability of winning is 3 out of 8, and 3/8 of 1,000 is 375. Now you might say, well, he should buy more just in case all of the more people win, because it is just probability, and that would be okay. But the important thing is that you've got this is your evidence, this is the basis for the number. Even if you then decide, apologies for that, even if you then decide that he should buy more, this is the really important bit, so don't forget to do the maths. Right, last question. A bag contains red, yellow and blue balls. The ball bag question. A classic example of the maths probability art. The probability of drawing a red ball at random is 1/2. The probability of drawing a yellow ball at random is x, oh dear. And the probability of drawing a blue ball at random is 4x. Work out the probability that a blue ball is selected. Give your answer as a numerical value. Well, we've got red, yellow and blue, and they've given us the probability for all of them. And we know that because there's just red, yellow and blue balls, all the probabilities must add up to 1. And that's because we've got all the options here, red, yellow and blue. So 1/2 plus x plus 4x equals 1. And 1/2, and x plus 4x is 5x, so 1/2 plus 5x is equal to 1. And now I'm going to subtract 1/2 from each side. So 5x must equal 1/2, because clearly 1/2 add 1/2 is 1. And 5x, so if 5x is 1/2, x must equal 1/2 divided by 5. And what is 1/2 divided by 5, I hear you ask? Well, simple, it's 10. A tenth to be precise. And think about that. There's 1/2, and we divide it into 5. 1, 2, 3, 4, 5, and of course there must be another 5 over here, so there's 10 in the circle. So that's what x is. So that means the probability of picking a blue ball is 4x, remember it says it here, which is 4 times a tenth, which is 4/10. You could of course write it as 40% or 0.4, but remember, not 4/10. If you write probabilities as a ratio, then you are basically saying, please don't give me any marks.